Hello there, and welcome to another Unity tutorial. In this tutorial, we're going to implement audio in our Floor is Lava game, which will really bring it to life. So I'm going to go over the basics of audio in Unity. So I'll explain audio sources, playing audio in a scene, including 3D audio, and we'll briefly look at like audio effects like reverb zones. We'll also discuss playing audio through code for different kinds of gameplay mechanics and events. And we'll implement some audio that just continuously loops across all of the scenes. So before we get stuck into implementing our audio, it's important to note in the project window, I have a new folder called audio, and inside that folder is all of the audio samples that we will need. So we've got some loops for different things through the mine, we've got 3D sound loops, we've got footsteps for the player, we've got jumping, we've got lots of different stuff, right? I'll go through these as we go through and implement each of them. But to start with, let's just go over, adding an audio source. So to begin with, I want to add some audio to this moving platform, right? So what I'm going to do here is find the prefab for it. So I'll open prefabs, and then we have moving platform, and just double click on that to open the prefab. And this is the moving platform. So here's the object with the script, and this will move between the points that gets listed, which is defined, when you create an instance of this prefab. So what we actually want to do here is add an audio source so that we can play audio from this object. So I'm going to click on add component, and then let's look up audio source and select audio source. So this is the component that's used by Unity to actually play audio clips. So here we can see there's a variable called audio clip which stores an audio clip, and you might have guessed this is the clip that the audio source will play, right? So we can change that through code if we want to, dynamically throughout gameplay, or we can just set it here and have it play a single sound. Then we've got a whole bunch of settings here. We'll ignore all these top ones to begin with. Mute obviously just mutes this audio source, so it can't output anything. But yeah, down here we have by default play on awake set to true. And in this case, we're going to leave that set to true because if that's ticked, then it means this audio source will begin playing the audio clip immediately when the game begins. That will become apparent why we want that to happen in this case. Now, the other thing we also want to turn on for this object is loop, because we're just going to give it a very short clip, but we want it to consistently repeat, right? Think of this audio source, it's going to play the sounds that follows this object around. It's like the sound that this object is actually creating, right? So, now we have a bunch of other settings down here. For now, we'll just leave that, right? And what I want to do is we want to set the audio clip. So we could drag it in from the project window. What's this moving platform? So I've got one down here, moving platform loop. So we could drag it in to the audio clip variable there, and that work. Or we could select it from our assets folder, and it'll be here. There it is, moving platform. Either way, doesn't matter. But yeah, now this object is set up to play some audio. It's not going to work the way that we intended to initially, but let's just see how it goes. And because we did that to the prefab, that should have also applied to all instances of our moving platform. We can see that we have this audio source here now, and it's got the settings turned on and the audio clip that we set. So let's hit play and see what happens. Okay, so the game's running. We can hear that there's audio playing, and that's my moving platform loop that I made that you can hear. If we pause the game, and if we disable this audio source, the audio stops, so we know that it's this audio source playing it. If we turn it back on, it resumes. But notice, no matter how close we are to our moving platform, it doesn't matter, it doesn't affect the volume. It's always playing at the same volume no matter what the distance is. And that's where 3D audio comes in. Okay, so to play around with the 3D audio settings, let's select our moving platform prefab again. We don't actually need to open it up in the scene view because the root object has the audio source, so we can just toggle it from the inspector directly. And if we come down to this setting here where it says spatial blend, right? And we turn that all the way up. So we've turned it from 2D to 3D. It's got a value of 1. This is a completely 3D sound. And what that means is these 3D sound settings will define the volume of the audio in relation to how far away the audio listener is, right? So if we zoom out just a little bit, yeah, like that. I'm going to change the minimum distance here. Let's say if you're like 5 units close to the object, you'll hear the object or the audio source at full volume. And if you are more than 15 units away from the object, you will not be able to hear the audio source play. So if we select our moving platform in the scene here, we can see we have a sphere. Actually, let's just open it up in the print. Yeah, but we can see it a bit better here now. So we have two spheres here now that correspond with the maximum distance, which is the outside sphere, and then the minimum distance, which is the inside sphere. So when an audio listener is within the inside sphere, they're hearing this audio source at full volume, and as they move towards the outside sphere or the edge of the outside sphere, the volume gets less and less and less until they're outside that sphere, at which point they'll be hearing the audio source at its lowest volume, which by default, the default logarithmic curve sets the minimum volume to 0.3-ish. So when you're outside this sphere, you'll be hearing the audio source play at a volume of 0.3. We could change this to the linear curve, and we can see the fall off here is a lot more straightforward. It goes from a maximum volume of 1 to a minimum volume of 0, right? But this space between this point and this point still represents the fall off as the listener moves away from the minimum distance here. So with that done, if we go back into play. Okay, so it's playing now, and actually what I'll do is I'll select my moving platform. So the audio listener, right? The audio listener is attached to our main camera. We can see here's an audio listener component here. And if we select our moving platform and actually have a look at the curve here, we can actually see the position of the audio listener in relation to this specific audio source. So if I go ahead and resume the game, you'll see as the platform moves away, the listener moves away, and as it gets closer, the listener gets closer, and the audio dips in and out based on our distance to the object, right? So we're on it, we're in this space here, so it's playing at full volume. If we were to leave, as it gets quieter. Okay, and that's pretty much all there is to 3D audio. Doppler level controls like how the pitch changes, when you're moving past an object with an audio source, or vice versa, when an audio source is moving past you. Sort of accounts for the speed and changes the pitch that the audio source is playing at based on that. And then spread is how the audio 3D sound, is distributed in speaker space, right across speaker space. So we're not going to worry about any of that. But we do have a couple of other settings here on the audio source that I'll quickly run through. We'll ignore these ones for now. I'll talk about them shortly. We went over mute, play on awake, and loop. priority defines like how much of the audio source or which audio sources should play over another, because as you can imagine, you might have like lots of audio sources in your scene, so this controls, you know, the priority of different audio sources. Then we have the volume, which is how loud the audio source plays. We have the pitch, which obviously changes the speed of the sound and how it sounds based on the speed of that. We have the stereo pan, so you can force this audio source to only be heard through the left stereo channel or the right stereo channel, or in the middle for both. And then, yeah, we went over spatial blend, and then reverb zone mix is how much of this audio source actually gets like mixed into reverb zones, which I will go over in a bit. But that's our moving platform done. So let's go ahead and do another one. Let's do the death wall, because actually it's going to be pretty much the same. So what I'm going to do is I'm going to right click on the audio source from our moving platform object or prefab. So right click on that audio source component and go copy component. And then let's find our death wall prefab. Here it is. Right click on a component, go paste component as new. And here it is. So the only thing I want to change about this audio source is the clip that it plays. So in our audio, I actually have a death wall clip here. Thankfully, I've named everything appropriately. Whoops. So this is now set up. Now I don't have a death wall in the scene to test this out, but if we would drag this prefab into the scene, you know, it would make the sound, but it would cause errors because we need to set it points and everything, and I'm not going to do that. So the next thing we'll do is we'll work on our triggers, so our score triggers. So like this one here, for example. So again, we're going to work with the prefab, and I'm going to right click on a component and paste our audio source component in again. Let's just open the score trigger. Now I'm going to change a couple of things here. First of all, I'm going to give it the trigger score loop, and we'll put that in there. And then I just want to change the minimum and max distance. So let's say you have to be a little bit closer to start hearing the score audio source for the score trigger, and a little bit closer to hear it at full volume. So that's that one done. So we'll exit out of that prefab. And the next trigger we'll do will be the end trigger. So again, I'm going to right click on a component, paste in our audio source component that we copied, and find my trigger end loop. Just drag it in. Let's, alright, maybe we'll make this one, 15 is pretty good, and 5 also pretty good. Maybe we'll make this slightly larger, like 8, so you can hear when you're near the end within reason. Okay, so that's all of those triggers. Let's hit play and just listen to what that sounds like. Okay, so we have a few different sounds going on now. So we can hear the score item trigger when we get close to it, and it disappears. There's another one. Oh, I missed. There's another one over here. Let's try for that one. Let's check that one. That's the moving platform we're hearing. Yep, we can hear that. Let's just check our end trigger. And that's it there. And we can hear it. Excellent. Okay, we've actually got one more 3D sound loop that plays automatically to implement, which is lava ambience. So just sort of like some room ambience. This is what it sounds like. So it loops. And what I'm going to attach this to is the room itself. So let's find our room 1 prefab and open it. So first of all, let's go to add component and add an audio source here. And right off the bat, I'll just drag in my lava ambience loop. And we want this to loop, so we'll make sure loop is turned on and play on awake is on. Now for this one, I want this to be 2D. I want you to hear this no matter where you are, because it's kind of like the overall ambience for the room. So I'm going to leave spatial blend to 2D, and we don't need to worry about any of the 3D sound settings. However, I'm also going to attach another component here. So let's go to add component and just type in audio. And here we're going to add an audio reverb zone. So let's turn that on. So even though this isn't a 3D audio source, so you know, there is no min distance and max distance, we still get circles for it, but you know, it doesn't actually like matter because we're not using 3D audio. We also get two spheres for the min distance and max distance of our reverb zone here. Now what this is it represents the max distance you have to be from the center to start having reverb generated by this effect applied to an audio source. And the minimum distance is, you know, when it's applied in full. So any audio sources within this inner circle here will have reverb generated by this effect applied to it in full, unless the audio source has bypass reverb zones turned on. And yeah, as you move away, outside and away from this inner sphere, the reverb will become less and less until you are completely outside of the outer sphere, at which point reverb will no longer be applied to the audio source. So I'm going to use this to sort of make all the audio sources within our room sound kind of echoey, like they're in a cave. And there's a bunch of presets we can actually use here, and there's one called Cave. I'll leave you to play around with these, but let me just show you what the actual effect is, right? But actually, before we do that, let's just adjust the distance. So max distance I'm not too worried about here, but I want the minimum distance to affect like everything. So let's say like 26, and let's just say 40, right? So that inner sphere is containing all, oops, my right mouse button isn't working too well right now. The inner sphere is containing the whole level. So if we go back and find our room, and you know, let's just have a look over here. Yep, we've got the audio reverb zone and our audio source. So let's hit play. Okay, we're in play mode. I'll just pause the game. All right, so we can hear the moving platform because it's close to us as well. Let's just resume and let it move away from us quickly. What can we hear there? There we go. All right, so let's turn off the audio reverb zone so you can hear it's you know, a lot less echoey. And if we turn it back on, there's some reverb being applied, which makes it sound like, you know, the sound is actually occurring in like a chamber, a contained room, or a cave in this case. And that affects all the audio sources. So if we actually just like resume the game, alright, so we can hear the moving platform now. Let's just turn this off halfway through. Alright. So yeah, you can hear that's creating or adding reverb to all of the audio sources. So just to demonstrate a little bit further, let's try changing the reverb preset while we're in play mode here. So we're on cave. Let's change it to, let's go underwater. Okay, so you can hear that the reverb makes it sound like it's more underwater, kind of muffled even. Let's try one other one. Let's go with, let's go dizzy. All right, let's try another one. Psychotic. There you go. That's got some really heavy reverb. So yeah, there you go. Okay, so now that we've implemented all of the sounds that automatically need to start playing when the game starts, let's go ahead and implement some of the audio for the various gameplay events and triggers. So we'll begin by finding our game manager prefab from the project window. And let's open the game manager script. So actually we probably just want to find the game manager script from the project window and open it up. Okay, so first of all, we're going to need to define some variables. So first, we're going to define a new serialized field, private variable, which will be of the type audio clip. And this is going to be a reference to the audio clip that we want to play when the player's score is increased. So we'll call this score clip. And let's give it a tooltip. So above that, we'll add a tooltip attribute. And he'll say the audio clip that plays when the score is modified. So we're going to need 3 more audio clips, all serialized. So I'm going to highlight the tooltip and the variable definition that we just created. And I'm going to duplicate that. So there's 4 audio clip variables in total. Then we'll go ahead and rename them. So the second one is going to be called, we'll call it lose life clip. And the tooltip for that will be the audio clip that plays when the player loses a life, right? The next one we'll call pass level, or we could call it win game or something like that. The audio clip that plays when the player reaches the end trigger. And then lastly, we'll have time up clip. And the tooltip will change the audio clip that plays when the game timer expires. So they're the 4 serialized variables that we're going to need. We're also going to need another hidden private variable. And this is going to be of the type audio source. And I'm going to give this the name SRC, a sort of shorthand way of representing audio source. So that's all the variables that we're going to need. So let's scroll down to the awake method. So in the awake method, what we want to do is we want to make sure that our audio source variable has a reference set to an instance of an audio source. That audio source will make sure is attached to our game manager object, so the same object that this script is attached to. So in the awake method, we'll just call try get component. And for the parameter, we need the out keyword. And here I'm just going to pass the name ASRC, the name of our audio source variable, and it will automatically detect that it's trying to look for an audio source component because that's the value or the type of our ASRC, our audio source variable. So with that reference set, all we need to do is go through our existing methods and play the appropriate audio clips at the appropriate times. So let's scroll down to our game over method. So here, what we want to do is we want to open an if statement first, right? Because we need to make sure that there is an audio source associated with our a source variable before we can actually use it. So we're going to say here, if ASRC is not equal to null. So if it has a value. And then we'll get access to our audio source. And we want to call a method called play one shot, right? And the parameter that we pass to this method is the audio clip that we want to play. So in this case, what we want to play is our timer or time up clip, because that's when the game over method gets called, when the timer expires. So by using this method, we don't actually have to set the clip of the audio source to play it. We just tell the audio source what clip we want it to play, and it'll just play that sound. Now, the other way to play an audio source would be to do it like this. So if we said audio source.clip is equal to time up clip, and then we said audio source.play, that would also play the sound. But by doing it this way, if the audio source was already playing a sound, it would cut out that sound, stop it wherever it currently is in its time elapse, and then play this new sound from the beginning. So this method here just makes sure that it does the previous sound, if there is a previous sound already playing, it won't stop that sound from finishing. So we just want to use play one shot. Okay, and that's all we need to do for the game over method. So next, let's scroll down to our level complete method here, right? So here, again, we're going to open another if statement and make sure that audio source is not equal to null. And we're going to grab our audio source and use play one shot again. Except here, we're going to call our pass level audio clip. Okay, and what we're doing here is pretty much what we're going to be doing for every instance in this script that we need to call audio. So I'm just going to highlight that and Control C to copy it. And let's scroll down to our modify score method here, and we'll paste it in. And here, of course, we're going to change the clip that it plays to our score clip. And then lastly, we'll come down to our subtract life method. And here, what we want to do is we only want to play the lose life clip if we have lives to lose. Otherwise, it's going to call game over, which is a separate clip. So here, we'll change the clip to lose life clip. So with all of that done, that's all we need to do for the game manager. So I'm going to Control S to save that, and let's head back into Unity. Okay, so I'm back in Unity now. So let's just find our audio in the project window. Actually, first let's select our game manager prefab because we need to work with that. Here we go. Okay, so we now have 4 slots for audio clips in our game manager script. So let's go ahead and chuck them. So event end, let's chuck that pass level. Event time up, that's our time up clip. Event score, that's our score clip. And event lava is our lose life clip. Now, the other thing we need to do with the game manager prefab here is make sure that it's got an audio source. So I'm going to click add component and look up audio and add an audio source. Now for this one, we want to make sure that play on awake is turned off and loop is turned off. We do not want this audio source to be 3D because we want it to be heard no matter where the player is in the scene. So we'll leave it as 2D. But we could, adjust the volume. But I think I'll go through and adjust the volume of all the audio sources later on. So with that done, let's find our game manager in the scene. Where are you, game manager? There you are. And just check everything's set. Yep, everything's set just as it should be. So let's hit play and see how it works. Okay. So let's try our score first. Right, so we have the 3D sound when we get close to it, but if we pick it up, we get a little sort of gong sound play. Alright, so let's try losing a life now. Let's jump into the lava. And we get a sizzle play, so that's the lose life clip and the score clip working. Let's try passing the game. And we get that gong at the end there. Okay, so to test the time up sound, what I'm going to do is I'm just going to change the time limit to 10 seconds and hit play again. Alright, so 10 seconds, 9, 8, 7, 6, 5, 4, 3, 2, 1. And we get the little chime sound, which is my time up sound. Good, so all 4 of those sounds are working. Okay, so now that we've done that, we'll go ahead and implement the audio for the mine agent. So let's find the mine agent script in our project window and open that up. Here it is. Okay, so we'll start as always by defining some variables. So underneath our existing serialized variables, I'm going to start by adding a header attribute, and we'll just give this header the title audio. So all of the variables that we defined underneath that will appear under a header audio in the inspector. We'll start with a serialized private audio clip. Actually, we just need to define 3 serialized audio clips here, and we'll call one default audio, and that's going to be the audio that the mine starts playing automatically. Then you could call it unarmed audio if you want. Then we're going to have another private audio clip, serialized, which we'll call armed audio. So when the player gets too close and it's about to detonate, this is what it'll play. And then we will have another serialized private audio clip, and we'll call this explosion audio. And we'll give these some tooltips as well. So we'll say the audio clip that plays while the enemy is not armed for our default audio, and I'll copy that tooltip and paste it for armed audio, and then just get rid of the not. So the audio clip that plays while the enemy is armed, and then underneath that for the explosion audio, we'll say when the enemy detonates. All right, so aside from those 3 variables, we are going to need another hidden private variable as well, which will be our audio source, just like for the other script, and we'll call it ASRC as well. So next we'll scroll down to the awake method. So in the awake method, what we want to do is open an if statement, right? And we're going to use try get component inside this if statement and see if that's equal to true, because we want to do some extra stuff if we are able to get an audio source reference. And we'll just say out a source. So that's going to try get an audio source component from the object the script is attached to, the mine agent. And if we can get that audio source, we want to do a few things. We want to set our audio source's loop property to true. We want to make sure it's looping, because 2 out of the 3 audio clips we're going to play need to loop. Then underneath that, we're going to set the clip of our audio source to our default audio, and then we'll start playing the audio source as well. So this way is the second way that I showed just before to play audio, and because we're not rapidly changing or playing audio through this audio source, we're using this way here. Also because we want the audio to loop, so we have to play it through the clip value of the audio source. Okay, so let's go ahead and start implementing the audio. So we don't need to implement audio in the start or the update. The first place we want to implement it will be here in on trigger enter, right? So underneath where we start playing the animation, we'll open an if statement, and we'll check that our audio source is not equal to null, just like in the other script as well, to make sure we can play something. And then we want to do something else before we reset the clip and start playing the next clip. We just want to make sure that the audio source, if it's currently playing, will just stop, so that we get no clipping when we change the clips, right? So then we can change our clip, so audio source.clip, and when the player enters the trigger, because that's what this outer if statement is checking, when the player enters the trigger, we obviously arm the mine. The mine gets armed and starts beeping, or will start beeping. So here, we want to set it to the clip to our armed audio, and then we can play our audio source. So I'll copy that chunk of code, because we're going to basically do the same thing across, multiple methods in this script. So next we'll go down to on trigger exit. So if the player leaves the trigger here, right? So what do we want to do underneath the animation? We will paste in our code here, and we'll check to see if audio source is not equal to null. We'll stop the current clip, and then we're going to change the audio clip back to our default audio, right? Remembering that this on trigger exit functionality will only be called if our AI is set to resume its behavior. So if that's not true, it's just going to go ahead and detonate even if the player leaves the trigger. But yeah, if it has been set to resume its behavior, we want it to go back to its other audio. So we transition back to that other audio. Okay, so that's 2 of the audio clips implemented. So next we need to go down to our detonate function, where we tell the mine agent to actually explode. Here it is here. And where are we going to do this? We can do it down here. So right at the bottom, we'll paste in our code. Now here we want to do something else, right? What we want to do here is we want to tell the audio source to stop. That's correct. But we don't want to play, change the clip or play using the play method. What we're going to do is we're going to set audio source.loop to false, just to make sure that, you know, what we're about to play doesn't loop. It won't anyway, because we're about to use play one shot, but just as sort of like a safety guard, I guess. So yeah, and then we'll use audio source.play one shot. And here we're going to pass it in our explosion audio. So that's going to play the explosion sound, right? Now we also need to think of something else here, right? So when we call the, when the AI detonates, when the mine detonates, we disable it after a certain amount of time. And that's done by this coroutine here, disable after time, where we wait, you know, for a certain amount of time before turning the game object off. So if, you know, say we have like a long explosion audio clip or whatever, if we play that sound and then turn it off before the audio ends, that's going to be really noticeable. So we actually need to account for the length of whatever this clip is within our disable coroutine here. So we'll start by creating a local variable and we'll call it despawn time. And for its initial value, we'll set it equal to our respawn delay value. Then what we're going to do is we want to check to see if our explosion audio is not equal to null. So we'll make sure that there is an explosion audio clip set. And if there is, we'll set despawn time, we'll add onto it. So we'll say despawn time plus equals then explosion audio dot length, which will give us the length of the clip in seconds. Then what we'll do is we'll come down here and we'll turn off, we'll just pass our despawn time. So with all of that done, all we should need to do now is save the script and go back to Unity and set up our variables. Okay, I'm back in Unity, so let's go ahead and find our mine agent prefab. And we'll scroll down, there's the script. Let's just get rid of the preview here. So first we need to make sure that there's an audio source attached to the same object as this mine agent, which is this root level object. So we'll just go add component, and I've already looked up audio source. So we'll turn off play on awake here. Actually, let's just open up the prefab, because the thing about this is we do want it to be a 3D sound as well, right? So let's turn spatial blend all the way up, open up the 3D sound settings. Let's reduce the max distance to like 10 maybe, zoom out slightly, there we go. And the min distance to like 5, or maybe 3, 4. We'll go with 4. And I'll also set it to linear roll off as well, right? So that we actually have to be within range of it to hear it. So we don't need to worry about any of the other settings here. We just need to set our audio for the mine agent. So let's find the audio in the project file. Here we go. So I've got mine explosion, that's the explosion clip. I've got mine unaware loop, that's the default loop. And then I've got mine armed loop, which is the armed loop. All right, so let's, do we have a mine agent in this thing? Yeah, we do. Okay, it's near the end. So let's hit play and test it out. Okay, now something actually has just occurred to me. To test this out properly, let's extend the detonation time of our mine agent. We'll make it like 5 seconds so we can test it properly, just so that it transitions back and forth with the audio appropriately. And the other thing is this end trigger, oh, hang on, where is it? Here. This is going to make noise next to my mine agent. They're just positioned right next to each other. So I'm just going to disable this audio source temporarily. So with that done, let's test it out. All right. Okay, so there's a humming. That's the idling sound. And yep, that's the armed sound. So let's see if it detonates. Cool. There you go. So that's the mine agent sound working successfully. Okay, so with all of that done, let's move on to the player controller for our footsteps and the jumping sound. So I'm just going to find my player prefab and open the player controller script. Okay, here we are. So as with before, we'll need to define some new variables. So we'll have serialized field, private audio clip, and we'll call this jump clip. Then we're going to have another serialized field, private audio clip, but this is going to be an array. So we'll put a set of square brackets after the audio clip type there, and we'll call this footsteps or footstep clips. Right. Then we'll have another serialized variable. It'll be a private float, and we'll call this step time. Right. And we'll give this a default value of half a second, 0.5 f. And then our last serialized private float, we'll call it sprint step multiplier, right? Or sprint step time multiplier, we'll call it that, because it's going to multiply our step time, right? And we'll also give this a default value of 0.5 f. Now I want to do something else with this variable in particular. I want to give it another attribute, right? Because I want to clamp it. I want to make sure that it stays within a value of 0 and 1, basically. We definitely don't want it to be 0, because if you multiply the time by 0, you'll get 0 and it'll just spam audio, basically. So we do that with a attribute called range. So you write it out like that, and we put our minimum value first. So I'm going to put 0.1f as my minimum, and then 1f as my maximum. And that will present the variable a little bit differently in the inspector as well, which we'll look at when we go back to Unity. Okay, so alongside those serialized variables, we are going to need two hidden private variables. So we'll have one float, and we'll call this step timer and give it a default value of 0. Then we are also going to need an audio source reference. So private audio source, which we call ASRC. So that's all the variables we'll need. So let's go down to our awake method and just make sure our audio source, actually we'll do it up here. Our audio source actually has a reference. So I'll say try get component out ASRC. So it's going to try and grab an audio source from this object. Okay, so let's go and implement our jumping audio first. So that's going to be down in the update method. Whereabouts here, where we have the inputs for jumping, right? So basically, yeah, when we press the jumping input, for both double jumping down here and for regular jumping, we are going to say if our audio source is not equal to null, then we're going to say audio source dot play one shot, and we'll just pass it our jump clip. And then I'm going to copy that and paste it down here for our double jump. Okay, so now we need to do the footsteps, and that's going to be done a little bit differently because we need to use a timer to play the footsteps based on the input. So let's scroll down to our apply movement method. Here it is here, right? And we'll do this after we've actually moved the character. So let's open an if statement, okay? And talk about the conditions under which we want to play audio. First of all, we want to make sure that there is an audio source, right? So we'll say if audio source is not equal to null, right? Aside from that, we also need to make sure that the character is grounded. We don't want footsteps to play if they're in the air, right? So let's check a second condition here. So we need to put two ampersands to separate the two conditions we're checking. And the second condition we can check is that controller If.isGrounded is equal to true. So if we have an audio source and we're on the ground, the next thing we need to check is that, some sort of input is being pressed. So we'll open another if statement. And in here, we want to check. So our inputs here and here are stored in the forward is stored in the Z axis of our motion step vector, and the right direction is stored on the X axis of our motion step vector. So if either one of those is not equal to 0, we know we're moving along the ground, right? Or the player's trying to move. So here we'll say if motion step dot Z is not equal to 0, or, so we need to put those two straight lines, I forget what they're called, but we need to put to them to separate the two conditions that we want to check. So if either of these conditions is true, it will execute this if statement. So the other one that we want to check is motion step dot X and make sure that it's not equal to 0. So if either of those is not equal to 0, it's going to do the following. So here is where we increment our timer. We say step timer plus equals time.delta time. And that will increment the timer from the time it took to get from the last frame to the current frame. Underneath that, we open an if statement, because here is where we check whether our step timer is greater than or equal to step time, right? So if our timer is greater than our step time, then we want to do the following. We want to say step timer is equal to 0 to reset the step timer. And then we're also going to play one shot from our audio source. And we want to select a random footstep clip, basically, right? So here we'll say if footstep clips, and then we need to pass it an index. And here we say random.range, and we want to pick an index between 0 and footstep clips.length, right? And that will play a random audio clip from our array of footsteps. But there's one other thing to consider in relation to this condition here, right? So this is checking it against the step time. But what if we're sprinting? We want the footsteps to play slightly faster, right? So if we're sprinting, so let's use the or condition here and check something else. So if we're sprinting, so sprinting is equal to true, and step timer is greater than step time multiplied by our sprint step time multiplier. So it's just checking it against a slightly shorter value than the regular step time if we're sprinting, right? Because this will be a value between 0.1 and 1. If it's 1, it's just going to return step time as whatever it is. But if it's between 0.1 and 1, it's going to return a percentage of that step time, right? So it's going to be a smaller value. And yeah, that should be the footsteps done. So all we need to do here is save the script with Control S and go back into Unity and set it all up. Okay, I'm back in Unity. I have my player prefab selected in the project window. So let's scroll down and have a look. So we have this new variable here for jump clip, and we have an array footstep clips. So we can add in a couple of audio clips there. Let's do that. So jump, there's jump. We're going to drop that into jump. And footstep clips, I've got like 6 different footsteps. Let's add our crunchy footsteps to our player. Okay, and then we have the step time. So this step time is every half a second, it's going to play a footstep, right? And then with our sprint step time multiplier set to 0.5, that means 50% of the step time, so 0.25 seconds, every 0.25 seconds, it will play a footstep while we're sprinting. Now, of course, the last thing we need to do is add an audio source. So I'll hit add component and audio source. Now we don't want play on awake. or loop to be on for this, and we don't want it to be 3D sound because this is just audio that should be heard everywhere because our game is first person. These sounds will be heard from the first person, so they won't be 3D. Now, with that setup, we should be able to hit play and test it out. Okay, so here we are. So let's jump first. Yep, let's double jump. Yep, that worked. Let's move around. Yep, that's working. And if we sprint, yep, it plays slightly faster. Okay, so that's all of the actual sound effects for the game implemented. The last thing that we can implement to add like a bit more ambience is music. So for this, I'm actually going to go to my main menu scene. Okay, here it is, very plain. I haven't, done anything to it since the tutorial where we created it. But what I'm going to do here is I'm going to right-click in the hierarchy and create an empty object, and we'll just call this Music Manager. And what we'll do here, I'll reset the transform just because habit. And actually, we will add an audio source here, right? So we've added an audio source component to it. Now, one thing we want play and awake on, and we also want loop on. But one other thing I'm going to turn on is bypass reverb zones. And the reason I'm turning that on here is because my audio clip, which I'll show you, where is it here? All right, so this is what my audio sounds like. So it's like kind of, very generic kind of chanting. It's a loop, which is why I'm looping it. But it's already got like a certain amount of like reverberance. So I don't want any reverb set up in the scenes to affect this object. So that's why I've turned on bypass reverb zones. And if I had any other effects, I would, probably turn on bypass effects as well. We don't want it to be 3D. We want this to be 2D. I do kind of want it to be like pretty quiet, however. So I'm going to set this to 0.3. I'll also drag my music track into the clip. Actually, what we'll do with the volume is we'll control it through the script that we're going to write. So let's go ahead and create a script in our scripts folder. Create C# script, and we'll call it Music Manager and open it in Visual Studio. Alright, so here's our new script. First we need a new namespace, so I'm going to get rid of those. We don't need either of those. But we will actually need to inherit from the Unity Engine.scene management namespace, and I'll go into that in just a sec. Now we're going to need a couple of variables. So we're going to have a serialized private float, and we'll call this menu volume. And I'm just going to duplicate that, and the second one we'll call it game volume, right? Maybe we can set it to default. So the menu maybe is louder, so we maybe say like 0.4, and the game volume, I'm going to set it to 0.1. Those are the two serialized variables we need. We'll also need a hidden private audio source, and we'll call it a source to store a reference to our audio source. Now we're also going to make a singleton out of this because we only want one of these music managers to exist in the game, because it's going to transition from scene to scene. So we'll create an auto property to store our singleton reference. So it's going to be a public static music manager, same type as this script, and we'll call it instance, and that can be publicly read but privately set. Then we'll need the awake method. So in the awake method, we need to set our singleton, right? So we're going to check to see if instance is not equal to null. So if there's already a music manager in the scene, we want to destroy this object, this game object, right? Otherwise, so we'll use an else statement. If there's no other music manager, we'll set instance equal to this. So this is our instance of the music manager. and we'll call a method called don't destroy on load, and we'll pass it game object. So that's a Unity method, and it basically prevents this game object from being destroyed when you change scenes. So it'll persist through different scenes. So that's that. Next, we actually need to set our audio source reference. So we'll say if try get component out ASRC is equal to true, then we are going to set our volume to our menu volume, and we're going to do another thing here, right? What we're going to do is we're going to just write a comment for now, but we'll say subscribe to scene load event. Okay, so the reason we need to subscribe to this scene load event is so that we can change the volume back to the menu volume if we're loading the menu, or to the game volume if we're loading a game scene. But before we can subscribe to that event, we actually need to create a method to subscribe. So let's scroll down. We don't need the update at the start, so let's just get rid of those, right? Okay, so underneath the awake method, we'll create a new private void, and we'll call it on scene loaded, right? Now we need to give it a couple of parameters here because it needs to match the signature of the scene load event, right? So actually we can start writing that in. Let's just start writing that in. It'll leave an error, but we'll fix it. So we'll say scene manager dot scene loaded plus equals, right? Because this is where we're going to add, actually we can do it now. We'll just say on scene loaded. That's the one that we are going to implement. And yeah, we need a signature that matches the scene loaded, right? And you can see here it takes scene and a load scene mode. So we need to create those parameters. So we'll just create a scene called scene and a load scene mode called mode. And now we write the functionality that we want to get called every time like a scene gets loaded. So what we actually need to do is check the build index, right? We know that our main menu should be the first scene in the list of scenes in the build. So it'll have an index of 0. So we want to see if scene, which is this one here, this is the scene being loaded, right? So if scene dot build index is equal to 0, then we're at the main menu. So we'll check if source, a source is not equal to null. And if it's not, we'll set the volume to our menu volume. Otherwise, so we'll counter that if statement with an else. So if it's not the first scene, we know that it's a game scene, right? So actually, let's just copy this, paste it in here, and change this to game volume. So yeah, now what that'll do is, yeah, where every time a scene is loaded, it'll run this, check which scene it is, and set the volume of this audio source accordingly. Now, because we're using an event here, we've subscribed to it, which means this method here will be called every time this event gets invoked, and it gets invoked internally, like I said, when a scene loads. So we've subscribed to it, but if this object gets turned off or destroyed, like for whatever reason, we can no longer call this method, but like in memory, this event will still be associated with this method. So if it got invoked, it would still try to call it on this object, but the object no longer exists. So if the object gets disabled or destroyed, we need to make sure we unsubscribe from this here, scene loaded. So, and an important note here is that we only subscribe to this event if we're able to find an audio source on this object. So let's just quickly add these as kind of safeguards. So we need to use a couple of Unity methods here. There's one called onDestroy, right? That's what we want to use here. So if this game object gets destroyed, it's going to execute this code, and we'll say if a source is not equal to null, then we'll go scene manager dot scene loaded, and then instead of plus equals, we'll say minus equals, and then the method that we want to remove. So I'll copy this here because we're going to do the same thing in another method, which is on disable. So if this game object gets disabled, right, not necessarily destroyed and removed from the scene, but just disabled in the scene, we're also going to remove this method from the event. And that should be our music, like ready to go. So let's save this script with Control S and then go back to Unity and set it all up. Okay, here I am in Unity. Let's just select our music manager in the scene and drag on our music manager script. There it is. We can see we've got the volume and stuff set up by default. So let's just hit play and see what happens. Okay, so it started playing the music. We can see the volume has been set to 0.4. And if we hit play, it loads the first scene and gets quieter. So let's, and you can hear it's not actually affected by that reverb zone in the scene either. So let's finish the level and see what happens. Okay. Oh. Okay, so we're about to go back to the main menu. It should get louder again, right? There we go. So it's still playing over and over again. It's not like restarting the track, but you can hear that it's louder now. Right. So that's the basics for, all the audio you'll need for this game. The only other thing I would do, I'm not going to do it in this tutorial, but the only other thing I would do is go through all the prefabs, adjust the volume levels for each of them to sort of, mix them and get a nice balance where, things aren't too loud or overpowering other sounds and stuff like that. But yeah, that's it for this tutorial. I hope you liked it and found it useful. If you did, please hit the like button. And if you want to see more game dev tutorials like this, then I'd encourage you to subscribe. Thanks for watching and have a good one.